Hello Year 9. This week we're going to look at how ideas of what an atom looks like have changed over time. Everyone should be able to name the models used in the development of the atom. Most of you should be able to draw the models of an atom, and some of you will be able to explain how experiments were used to develop those models of an atom. When you picture an atom in your mind, what do you see? Maybe like a picture like one of these? Before we start, it's important that you understand some of these key definitions. An atom is the smallest unit of matter, a bit like a building block. Experiments are procedures carried out to prove or disprove an idea or hypothesis. And scientific models are a way of seeing something for the world to easily understand it. Okay, so let's look at some of the scientists that have contributed to models of an atom. If you have read the fact sheets, hopefully this is fairly familiar to you. Democritus was a Greek philosopher who lived in 5th century BC. He said if he divided a stone in half, the two halves would have the same properties of the whole stone. Therefore, if a stone was continually cut into smaller and smaller pieces, at some point the pieces would become so small they would be indivisible. He called this atomos, for indivisible in Greek. His idea was rejected by Aristotle, another famous Greek philosopher, and ignored for the next 2,000 years. In the late 1700s, an English chemist called John Dalton looked at the idea of atoms again. He said matter consisted of tiny particles called atoms that were indestructible. They were solid spheres, and different materials were made up of different types of sphere. For example, clay was made of clay particles, sand was made of sand particles, air was made of air particles. 50 years later, evidence mounted that atoms weren't actually solid spheres and were much more complex. In 1897, J.J. Thomson discovered electrons. He said John Dalton's model did not account for positive or negative charges, and he suggested that an atom was a solid positive sphere with negative electrons dotted throughout, a bit like plums in a plum pudding. In 1911, Ernest Rutherford proved that the plum pudding model was incorrect using alpha particles and gold foil. He proved that actually atoms were mainly empty space and that there was a dense, positively charged nucleus at the centre of the atom. In 1913, Niels Bohr said that electrons weren't randomly dotted throughout an atom, but were in concentric circles orbiting around the nucleus, a bit like planets orbiting around the sun in our solar system. They were held in shells which prevented the collapse of the atom. He is hailed as the father of the modern model of an atom. Lots of experiments have since supported his theory, which is widely accepted with a few changes. James Chadwick, in 1932, identified particles with a neutral charge in the nucleus and called it a neutron. Lots of scientists have contributed to models of the atom, and at the time they thought they were all correct. We are confident that the current model is correct, but the only way to prove this is to continue to experiment. You are expected to be able to draw the 4 atomic models shown. Most of you should be able to label them. So we have Democritus' simple particles can't be divided any smaller model, Thomson's plum pudding model, the atoms are positive balls with negative electrons dotted throughout, Rutherford's nuclear model that has a positive nucleus in the centre, and Bohr's model that shows electrons orbiting around the nucleus. Some of you should be able to explain how the experiments were used to develop the model of the atom. In particular, why we moved from Thomson's plum pudding model to Rutherford's nuclear model. Scientists accept or reject models based on what they have seen or the evidence they have found during experiments. Without evidence, it is impossible to confirm or reject ideas. In 1897, Ernest Rutherford discovered electrons and proved J.J. Thomson's plum pudding model to be incorrect. Along with Marsden and Geiger, 2 of his students, he performed a series of experiments using alpha particles. In a vacuum, he aimed positive alpha particles at a thin sheet of gold foil and recorded the location of strikes on a fluorescent screen as they passed through. To their surprise, although most of the alpha particles passed straight through, as was predicted by Thomson's plum pudding model, a small number were deflected at an angle and a few ricocheted straight back. Rutherford concluded that an atom is mostly empty space, with a small dense positive nucleus at the centre and a negative electron surrounding it. It was considered one of the greatest scientific discoveries of their time and led to our current accepted model of an atom. Thank you for listening. Now you have to go back to Shareware and complete the form asking you 6 questions about the video you've just watched.